what we normally face in the traditional standard multidisciplinary model, right, that we find in the building construction industry, in the sense that the feasibility design, or let's just say the feasibility study, is done by a certain team, and then it's handed over to a design team who's supposed to develop the design in line with the business case or the feasibility study, and then it's handed over to a construction team who's going to try to realize the project, and then finally it's handed over to an operation team that is meant to operate the building afterwards. However, the issue with this is that people who are normally involved in feasibility, normally you no longer see them during the design, you no longer see them during the construction, let alone in the operation. So in that respect, what we have is, it generates a lot of gaps. The first gap that we identify is integration. Because things are done in stages and in silos by different disciplines, there's always this problem of integration. There's always some gaps and misalignments here and there. The other problem that we identify is validation. Because the project is not properly aligned and integrated, how do you validate its performance? Now, a lot of you know that from a capital cost standpoint, for example, which is relatively easy to quantify, is it doesn't make up more than 20% of the overall whole life cycle of the building. The operational cost, on the other hand, can make up to 80% of the whole life cycle cost of the building. And that is even more difficult to predict, right, and to align during these stages. Finally, we come to communication. If you have lack of integration and you have lack of validation, then what is it that you're communicating? So there's always miscommunication that happens here and there because of these gaps that we perceive. Now, the other thing is, BIM was supposed to solve much of these problems, right? However, while BIM brought a lot of solutions with it, it also brought along its own challenges. To start with, not everybody uses BIM. Certainly not during every stage, and certainly not at every level, right, within any discipline or organization. The second thing is that from a validation standpoint, BIM does not really have the tools to simulate everything. Like, say, for example, energy performance, right? Most BIM tools don't do that, or structural calculations, or, for example, financial modeling. Most BIM tools do not do that. And I've heard a lot of claims suggesting the opposite. From a communication standpoint, because not everybody uses BIM, it means that not everybody is aware of the day-to-day activities and the updates and so on and so forth. So in that respect, there are many, as I said, challenges and gaps that BIM brings along. So one of the things that we wanted to do from a strategic standpoint is to try to move away, or let's just say adapt the multidisciplinary model into something which is more dynamic and interdisciplinary, in the sense that we would have a core team that is specialized in whole life cycle design, constructability, operability, and research and development, especially when you have innovative projects, right? When we have innovative projects that require new solutions, new designs, we don't see a stage called R&D almost ever, right, in building construction projects. So in that respect, if we have this core team that starts with us the feasibility study, and then we maintain that core team throughout design, construction, and operation, at least you know that the criteria is being maintained and things are not lost or miscommunicated. Now, we are especially, let's just say, witnessing these problems or experiencing these problems and challenges when it comes to when we receive, for example, RFPs to do smart, innovative, let's just say, developments, even more so cities. Now, as you all know, that this is still pretty much a theoretical idea. There are a few smart buildings here and there. There are a few small smart developments here and there. But an actual full-fledged out smart city is really still theoretical for the most part. So if you go into Google and you type smart city, you're going to get a lot of these similar diagrams. They look fantastic and amazing, right, from a graphical standpoint. However, when you want to try and adapt them to actual, scenarios, say, for example, in Riyadh, how many of these smart city theories have taken into account sandstorms, right? Or if you want to apply them in a place like Neom, where it's very remote, it has no infrastructure, right, and so on. So in that respect, you start seeing a lot of struggles, if not failures, when you try to adapt them. Because for the most part, as I said, we're using new and old assumptions and theories. Also, much of the technologies are being borrowed from other industries, so they were not really done for building industry per se. And therefore, we create these models, these generic smart city models, which, as I said, lack contextuality, adaptability, and for the most part, they are untested and potentially non-viable. Another big challenge is that when you bring all of these consultants on board to help you to create these models, right? They speak different languages, they produce their information in different formats, right? And they use different logics and so on. So to have a party, be it a person or a group, being able to read all of this information and create the bigger picture in their mind, we call it creating the mental model, right? It's a very, very difficult task indeed. So one of the things that we thought we could do is maybe create a tool that can help us, at least from a high-level executive standpoint, to capture the essence of what all disciplines are producing, right? And integrate them together so that we can get a clearer picture. As I said, this is especially targeted for executives because people who are involved on a day-to-day basis, they have a better understanding of the project. Executives, however, who need an executive summary, right, which you cannot provide it in BIM, you cannot provide it in digital twins, and so on. This is basically what we're aiming for. And my colleague Greig here, Dr. Paterson, is going to present a case study to demonstrate how we tried to do that.
Yeah, so as Majid mentioned, the best way to demonstrate this is just to walk you through a very quick case study. So this project is somewhat confidential. I'm sure many people in the room recognize it. It's in Saudi Arabia. It's in a very challenging mountainous region. The strategies within the project are also very ambitious, very futuristic architecture, carless mobility, digitization strategies, very stringent sustainability goals, and all of this mixed with a very large design team working on different parts of the design. So our challenge was, how do we integrate all of this together? A, and then B, how do we communicate this to key stakeholders, and particularly at the board level, who are not necessarily engineers and designers. So the process to create the tool that we described earlier was first to constantly collect data from the design team. So this is 3D models, engineering Excel sheets, reports. We then go through a process of categorizing all of that data, lining it up depending on if it's text or if it's visual, enabling it to be fully connected and interactive. We then begin to create the model in a bespoke way for each project, creating the interface and setting up the networking, and then finally it ultimately will be used for data visualization in a very user-friendly way at the board level. I think it's best to jump straight into a video demonstration.
The Interdisciplinary Design Model, or IDM, is a high-level executive summary digital interface. It assists users in visualizing key project information for innovative, smart, sustainable projects. The assets and infrastructure within the IDM are fully interactive. For asset data, the IDM has a large 4D interface and data visualization panel on the right-hand side. The interactive data menu contains information on each asset, including name, areas, water demand, and cost. For GFA, data can be visualized for individual assets as well as for the complete master plan. This information can be filtered to show, for example, a particular cluster. Data can also be easily shown for land use area and population. Technical performance, including energy consumption, can be explored at different scales. The capital cost breakdown for the entire master plan can be shown and visualized for individual assets and infrastructure items. Operational costs are also available. In the infrastructure section, key information on access routes are shown, including typical cross-sections and vehicle types for each selected route. The final main section shows the design rationale. The design rationale offers an overview of the project by providing a summary of the master plan at different scales. The method gives a high-level understanding of what each major component of the master plan is, and importantly, why each component is planned the way it is, starting from the country and master plan levels, moving to the infrastructure, asset, and landscaping levels, and finally to the cluster and asset levels. For selected assets, a range of analysis can be explored. For example, for the vault, annual solar radiation can be visualized, for the landscape, and facade. Wind flow can also be explored from different angles. In conclusion, this platform helps users formulate a high-level, full-picture understanding of innovative, smart, sustainable projects in a user-friendly and interactive visual fashion.
Just important to note that depending on the complexity of the project, a different type of model would be fitting for it. So we start off with text and simple 2D diagrams, and before moving all the way into 3D and 4D interactive models. But the key for all of them is to be very simple, lightweight, agile, and user-friendly.
Thank you, Greg. So yeah, effectively, what you've seen is this is not an attempt to replace BIM or digital twins or to replace 2D drawings or reports or the usual things that we normally produce. This is, however, an attempt to try to bring them all together in one environment in a high-level executive manner, because, as I said, so that people who don't have the time or don't have the skills to browse the other information be able to do so and still understand what the project is about. With that being said, and as Mr. Haroon demonstrated nicely just a second ago, if we, for example, combine immersive technologies, right, along with this IDM, then people will be able to experience things, right, in a more interactive way as well.